Good evening, everyone. We will make sure this is recorded in case anyone wants to play it back at a later date. So I guess I'll just jump into it. So this is Nick here, and I'm going to try to keep this to around probably an hour. I mean, I could potentially talk about this, for all night, really. But try to keep it around to an hour, maybe an hour and a half tops. We'll see how it goes. Just kind of detailing this app, RadioLand, that I've been working on the past several months, and give you some insights into everything that sort of went into the design. It's in no way in doing this am I proclaiming it finished. It's definitely not from any standpoint finished, but just to sort of commemorate the launch of the app. So let's get into it. And also thank you for anyone who checked out the 3-minute thesis yesterday. Second prize, really cool. So thanks to anyone who might have checked that out as well. All right, so let's get into it. So what I'll do is I'll kind of talk about just where the concept for the idea took place, where it came from, talk a little bit about the propagation algorithm that kind of fuels the whole app. Some of the features, we'll do a little demo. Obviously nothing groundbreaking if you've used it before, but we'll still check it out. Some of the design software-wise, and then some of the things that still have either been revealed as missing or some issues or some new feature ideas that we have on the roadmap. So I'll get into that as well. So, if you know me from DXing or you know me from radio exploits or who knows, but I am again Nick Langan. I'm currently a software engineering student at Villanova in their master's program, and I've been a WTFDA member. I'm actually on their board of directors for 17 years now. Well, not the BOD is recent, but been a WTFDA member that long. So, as far as DXing, that sort of, coincides that period of time. And Bryce Foster, who I'll mention a few times throughout this, very important part of RadioLand. I do a podcast with him, so check it out, the VHF DX podcast that we do, periodically throughout, the past few months. So check that out as well. So, but very active. I've always been interested in radio. That is like the the genesis for a lot of this idea. And so I'll sort of go back in time a little bit as to like where where this originally even came from for me. So for me, growing up in the 90s, I'm old enough to remember, obviously before the smartphone, before there were radio guide type websites, which I'll mention a couple of them later. It was more in the book form. And I know a few folks, mentioned like the M Street Journal. That was big. I think that started in the late 80s. I'll talk about the FM Atlas. But for me, it was a trip to Boston, just a family trip in the summer of '95. I'm quite positive that was the year. My dad was business traveling. We all went with him. I remember we were staying in the Copley Square, one of the hotels down there, and just they have the underground mall there, and they had a bookstore, and this book. Now I inserted there a Billboard article. This book had just come out in July of '95. I think literally the same month that we were probably there. And the reason I remember it so well is the other, focal interest I've always had is in smooth jazz music. I remember picking up this book, and why we ended up buying it. By then, I already had an interest, just using portable radios. It looked really cool. I remembered it listed WPLM, the station 99.1, same calls, still on the air from Plymouth. It had listed as jazz. And as it turned out, I think also just like right around that time, it had picked up the smooth jazz format, was going by Smooth FM. So I remember thinking that was so cool, that there was a book. Now the way it kind of worked is in like a listing form by state. It had stations and formats, and then it was not comprehensive as far as the stations it listed, but it had various cities and then like a symbol pertaining to these signal strengths of the stations, and then also laid out the stations on a map. So I thought it was really cool, and they published it. The gentleman who I think is still around, he does not write radio books anymore, but I did some LinkedIn sleuthing. Jeffrey Dingle is the gentleman's name, still up in the South Shore of Mass, I'm pretty sure. That, I thought the idea, and in that Billboard article I have from the great website, AmericanRadioHistory.com, which archives Billboard, which archives Radio and Records, lots of other good publications as well. I found that, and they did an interview with him, and he said the inspiration was, he was getting in his rental car, and he, in taking a trip somewhere after flying somewhere, and couldn't find a station to listen to, seeking, on his car radio. And so that was the genesis to write this book. And so, it's funny. Obviously, the landscape has changed dramatically from 1995 to 2022 now. But in essence, that kind of remained the same issue, at least with my mindset for RadioLand. So that stuck with me. That definitely did that book. I think I have a copy of the 97 version around there somewhere. And I included the whole Billboard page because that's actually, I think, a picture of Vanessa Williams meeting Pat Prescott at the old CD 101.9 studio, the great former smooth jazz station in New York City. So I had to include that whole thing. So yeah, and as a kid, doing many road trips on the Pennsylvania Turnpike back and forth between Ohio and New Jersey. This was a common sight. And so, just remember, tuning around for stations, not really knowing what was what. So, that again is another memory that sticks with me. And so, I'll be writing quite a bit, and, I'd be curious, anybody who, was particularly moved. I know a lot of DXers were, as far as the FM Atlas, have, any, favorite memories, traits of it. I want to write quite a bit about it in my actual thesis paper, as sort of a, doing a little early background on the idea of radio guides or travel-based radio listings. So while I ended up getting a copy, I think, at one of the Dayton Hamvention Hamfests. I never, had quite relied on the FM Atlas like some of you probably had, but that's definitely like ties into, I think, the whole concept. A couple of other, 100,000watts.com was a very popular, kind of short-lived, but very popular listing of radio stations, late 90s, early 2000s, I believe before Clear Channel ended up buying it. A lot of people like that site a lot. it had, as soon as like a format change happened, it was up to date. Good listings for affiliates. I remember that was like, if you, for, the DX use case, if you were trying to track down, if there was a, Westwood One affiliate, carrying something, like it had it all, 100,000watts.com. So, and it was also subscriber based as well, but it was a very renowned site. And then obviously, like, I always use Radio Locator. Like, that is an excellent resource. I've always just liked the concept of putting in a town and getting like the local dial, with the different thresholds. And so, even as, it has mainly stayed the same, I would say, within the last 20 years or so. But even so, I still make use of it, particularly during DX season, when there's a, band opening going on, or, just afterward, for DXers doing a lot of audio review. Even with the new tools, I find myself often just going back to Radio Locator. You can search from a different location, search by frequency, get the coverage maps. If you've used it, you know exactly what I'm talking about. Obviously, the only downside is for like the free version, there is a limitation as far as how many searches you can do in a day. So, and then we'll get into a little bit, how they generate their signal strength predictions. It works fine for them. It's worked fine for them for at least 20 years as far as a business model. But there are some flaws, I guess you could say, and that was part of the inspiration to look at building a mobile app to maybe do something different. So get into like an initial prototype of RadioLand. So again, so I myself, as far as like writing software and coding, like this is still a pretty new thing for me. Because so I finished my undergrad program at Villanova in spring of 2020, and it was, I had re-entered in the fall of 2018, and it was only then. I mean, I had, as far as like coding experience prior, HTML that was not that complicated, dating back to like the Angel Fire days of building websites and things of that nature. Nothing, and then maintaining some WordPress sites, nothing sophisticated at all. So really, my first foray was entering this program, and then going through the various computer science courses that were required. And so I learned Java, which is the standard at Villanova. And, that's when it sort of clicked for me, like, wow, I really like, using this. Coding seems really cool. But never actually building, it also, I never made the connection of like building a piece of software, how to do that, until as a required course in this program. There was a software engineering course in the undergrad program that I took in spring of 2020. And so my Professor Obermeyer, who now happens to be the advisor for this project, the requirement was to map out sort of the whole life cycle up to a prototype of a software idea. And, as soon as I was paired with another student, and, instantly the radio concept idea of some sort of radio location application came to mind. And so the purpose of this exercise wasn't to like build a working full-fledged application. It was only over the course of one semester, But what ended up happening was, first of all, the name came to fruition, RadioLand. So Sam Rizzo was my partner for that whole semester, and he came up with the name, and it just sort of stuck. So thank you, Sam. And so we got this very, very basic prototype. And I remember we built it in a cross-platform. It's certainly still around. Framework called Xamarin. And it was. I'll get into what RadioLand was actually built in a little bit later. It was a rough experience actually, as far as like figuring it out. But it was my first foray ever into mobile application development, and really any kind of like legitimate other than like console Java program software development. So it was a great teaching tool. And so I had always after that, again, this was spring 2020, and then the world obviously sort of shut down. I kept it in the back of my mind that if I get this chance again, because I remember during the whole process, I solicited some feedback from several different DXers about what they would want in a radio location app, sort of as an alternative to Radio Locator. And some of that stuff I legitimately was able to reuse, since again, it was not that long ago when actually planning this. So this was, foundational for what was to come, I guess you could say. So I just want to say hi to. Looks like we got 8 folks on now. So very cool. Thanks for jumping on. All right. So let's continue. So the timeline sort of went. So I joined the Masters in Software Engineering program here at Villanova after I graduated in spring 2020. And within that program, they have something called a Grand Challenge, which is basically just a 3-credit initiative as opposed to taking a course. It's not required, but if you take it, it ends up being you get to, embark on some sort of software project. You need an advisor, and just sort of a plan of, what's the idea, what's the concept, how to go about things. And, as soon as I joined the program, this was something, I very much wanted to do. And as a result, I ended up, registering for it. And so, instantly, Professor Obermeyer became my advisor. And RadioLand was the app that I wanted to build. And so the semester that was scheduled for was this past fall. In preparation, I just, I wanted to set forth to see if we're going to build this app, we wanted to do so, obviously first making some type of predictions as far as FM signal strengths go. So what options were out there? There's the established contour data that's right on the FCC website that you can, easily download. There's quite a bit of it, but it's there. It's there for you, to use, that they make available. And what that is, that basically reflects the service contour of the particular station or stations, and you can kind of extrapolate from that what their coverage area is. That's essentially what Radio Locator does. That's what, a lot of other different sites that, there's a lot of sites that rely on just the raw contour data. So that was an option. There have been a lot of propagation studies done, like Wi-Fi, cellular-wise, that, just within the last 5-10 years, the proliferation of devices, 2.4 gigahertz, 5 gigahertz, that are out there, but wouldn't necessarily pertain to FM down in 88 to 108 megahertz. So that really wasn't a viable option. Machine learning, that was something that, seemed appealing at the time, just from taking a couple introductory courses. But to be able to build a model that actually made, reliable, sustainable predictions, let's say training the model on, say, the effect of signals, somewhere in the Rockies, or, the differences in terrain, in the Appalachians, to be able to put together that sort of data set and then train the model, we'd be talking years as far as like getting reliable predictions from that, and a lot of other details and just overall knowledge that I would not have to be able to build such a model. So from a high level, machine learning seemed possible. Maybe do like what's known as a random forest model, and maybe get some more accuracy where there are terrain differences. Mark in Little Egg checking in. Thank you. We do have a chat open, so thank you, Mark. So that's so that was a not going to be a viable option at all. And then you could just do based on distances, as far as 40 miles, maybe use some sort of mileage threshold, as far as from the transmitter of the station to wherever you're located. But that would there's many different reasons why that would not be suitable, just relying on distance. There's obviously many different station classes as far as signal strengths go, what they're allowed to transmit, like the maximum ERP, the maximum height above average terrain that's in a station class. And so, as a result, like not all stations are equal, and we'll go into a few other reasons as to why that wouldn't be viable. And actually, here is a very good example. So not only are we dealing with station classes, but so in the US alone, there are many stations that use directional antenna patterns. And now this is straight from the app. So I think this is probably the best case of like short-spaced directional stations that's around, basically. There's probably a few others in the eastern U.S. That are certainly short-spaced assignments, but I really like this one. So this is in the Baltimore, D.C., York, PA corridor here. So you have 105.9 WMAL FM down there in Woodbridge. I think the tower right where 495 and 66 meet. That serves the DC market, city grade signal in DC. They are directional though. So basically they, send only a percentage of their full power toward Baltimore, where WJZ FM transmits from on 105.7. So that is an adjacent, they're not on the same channel, but for two markets that are really close together in Baltimore and DC, that's that in itself is a very short spaced, I think we're talking about 40 miles. That's very short spaced to begin with. So if you were just going by distance, not factoring in the directional pattern, you probably would predict that 105.7 from Baltimore would be able to be heard in much of the DC market if you were just going by raw distance, not factoring in, that they're only sending a percentage of their power because of the directional pattern. And to make matters even more confusing is on the same channel, just up I-83, WQXA transmits on 105.7. And they, are on the same channel as Baltimore or Catonsville, I think is their city of license. Probably one of the, I would have to say that is the most extreme same channel example that's out there, as far as QXA and Jay-Z goes. So all to say, like, the reason why I mention this is if you're building some sort of app to, or just any sort of application to make signal predictions, you've got to factor in that there's some real tight, short spacing, either because of grandfathered assignments, gentlemen's agreements, agreements for interference to accept interference. And to some degree, I'm actually not compensating for that as far as, if there are two channels or two frequencies on the same channel and, they're not running directional patterns. It's not like I'm blanking that frequency out in the app. But what is important to factor in is that these three stations are all running different directional patterns. And so, these are the types of factors that would just be, if you were just taking the distance of the station alone and just trying to make some sort of prediction off that, that's, that would not be, suitable, at least for accuracy purposes. So, using the contours, let's, get back to that. So, one thing to know, I think that's very important. The contour data only considers, terrain differences between 2 and 10 miles from the transmitter. So what that means is if there's a, mountain range 25 miles away, in between where you're listening from and where the station is, that's not going to get factored in as far as the contour prediction is concerned. It's the average terrain height of those 8 miles that determines how far away a contour line gets drawn in a particular direction. So you can see where, as far as, within the city grade coverage of a signal, that's perfectly fine. That's, that's more than suitable. And in a lot of cases, that'll work okay. But if you're, suburban fringe, I'll go over a few examples of that, that potentially could be missing out on, if there just happens to be a pretty large mountain range, 20 or 25 miles away from the transmitter, that could be a big deal. So there are some limitations as far as extrapolating those contours. For the city grade coverage, the very local part of the signal, sure. If you go beyond that, maybe not so much. So that brings me to a study that was conducted back in the 60s, that specifically, I think the purpose was for guiding aircraft through very rugged terrain. This was just when computing technology was really on the upswing. And so a pair, Anita Longley and Phil Rice, at the Central Radio Propagation Laboratory, this has been part of my thesis research, developed a model for measuring transmission loss, as it were, over regular terrain. It's known, I think, formally as the ITM model, the irregular terrain model. And so basically it can be, I don't want to say programmed, but yeah, it could be configured for different types of climates, different type of terrain. Terrain data is what is so important for making this model work. In order to use it, if you have an implementation of it, you have to supplement it with, working terrain data, because that's everything to this model. And so it began to be used, commonplace in the 60s, military applications, and then for TV broadcasting, and the FCC still uses it today. And Anita Longley was actually quite the pioneer at the time where engineers, as far as women engineers, that was almost unheard of back then. And she was hugely instrumental in making this propagation study real, and I think contributed to 20 other published papers. I think was part of my research. So really cool. I had no idea it was, even remotely available, at least, going on here early in summer 2021, as it were. And so this is where, at this point, trying to analyze different ways of potentially making signal predictions. I remember having a conversation with Bryce Foster, again, my VHF DX podcast compadre, and he mentioned getting in touch with Trip, the overseer of rabbitears.info, which, if you are a TV DXer, which I am really not, but if you are, or just, a TV viewer, a TV enthusiast in general, and actually now they have a great FM autologger as well. But specifically for TV, it is like a Bible as far as the listings, the signal strength coverage maps, the signal strength predictor that it has. It has a wealth of resources, and of course the autologger that I know so many DXers love for TV as well. Bryce suggested I get in touch with Trip, and so I did, and it was Trip who really suggested, well, the FCC makes an application available that, essentially produces field strengths if you configure it such using Longley-Rice. And I really didn't, at that point, I had very little, idea of what that even was. But that opened up this avenue as far as, making this possible. Because, at the time, other than, again, doing contour extrapolations, which at best would, give what is already being done as far as signal predictions online, there were very few other avenues. It was not like I was going to invent something myself. So Rabbit Ears is like the shining example of an implementation of Longley-Rice, or at least using it as far as making predictions. There's a couple other sites that I'm pretty sure use it. So FM Fool, which, a lot of people like, a great resource. I think it looks like it has been basically abandoned, sadly, as far as, you can create like the dial at a certain location. It'll tell you if the propagation is one edge, two edge, or a line of sight, and then it'll spit out a field strength. And I'm pretty sure, based on your location, the field strength that's generated is generated by Longley-Rice. I'm almost positive of that, and I think fmscan.org might use Longley-Rice. I was trying to figure that out myself. That is another site. It's definitely more of like a technical audience that it's geared toward, but you can put in a location there, and I'm pretty sure it generates field strengths that are Longley-Rice based. So that is another resource. But overall, I don't want to say it's never been used for FM signal prediction, because that's totally wrong. It's more, I would say, RF engineering, I think radio groups probably use it. Studies to license new applications definitely make use of Longley-Rice. But in a consumer application, that had seemed relatively untapped as far as like a common person, even a DX use case. So it seemed very appealing once I found out about it. And again, that was all thanks to Bryce and then Trip for giving me the total insight on how to access it, which I would have had no idea how to do myself. So what should such an app look like as far as RadioLand goes? Like, what was the idea in my head? And it's not like I was, static or, just totally attached to a particular concept. These are some traits that, I had been thinking about that are largely logical. You want a database that's up to date regularly. I would say daily. I think that's, reasonable. You want to use the user's current location. I think that was a big thing. Not like guessing, not like, center of town zip code or something like that. If if they allow it, the app should pick up what their exact location is, or whatever is the closest as far as the device's GPS. You should have the ability though to search for a specific location, and those results ideally should be A on a list, but also B on a map. You could filter by the different, high, medium, low, weak, fringe, medium, whatever you want to call it. Lots of search options. And a big thing, too, for me, which, I had no idea if it was going to become a reality or not, would be coverage maps. And I think an important thing in any good piece of software for sure would be just simply responsiveness. I remember early on, in the fall semester as this was being built, being very concerned. I remember talking with Professor Obermeyer about the length of time it was taking for some of the early search queries, because I had found a way to do it to make the Longley-Rice predictions. I'll talk about the software design a little bit later, but calling out to my server. But it was taking, probably around like 8 or 9 seconds for like the medium category. And I think we wanted that under 5 seconds. Like that should, if all things are being equal, if your connection is good, like there's no reason that it should be taking that long. So, the way the predictions were being made, we found a way to do it, but sort of the method to make that call had to be changed a few times, just because, you do want some sort of benchmark as far as ideal responsiveness. So, that would be more of like the non-functional requirement, I guess you could say, for the software. That's obviously like a no-brainer, but I think that's very important when you're talking about a mobile app and you could be traveling. You want that data fairly quick. All right, so I think at this point I will so maybe some of you have checked it out already, and looks like we've got 11 folks on the stream now. So thank you, very on a Saturday night, with plenty of other things probably to do. Although I guess it is the middle of February, but thank you for checking this out. It's really cool that that we're able to do this, and thank you for your interest. And again, it's been really cool this week, because not only we had the Villanova 3-minute thesis yesterday, but I officially announced it. I guess you could say that the app launched. So posted it on a couple different sites, and the response was really good. Made me very happy. Like any software developer, in its infancy or not, you want people to like what or be interested in what you're building. So it's very cool. So I figured I'd go through just some of the core traits of the app. There's probably a few things. There's more than a few things that I probably have not explained particularly well in some areas, or maybe some things that just would fly under the radar. I may miss some things going through it, but I'll do a little demo and hopefully it'll translate okay to this YouTube experience. So bear with me a second here. We'll see if I can execute this properly. Okay. So I was toying around with how to show the demo. I have, on the computer here, just the MacBook I'm using, an emulator. And so, so many hours were spent over the past couple of months, using this emulator. I'll go ahead and show it. And so I could, basically what this does, this is simulating an iPhone. I guess I disappear if I do this, but that's no loss. But I could also, I think I'll eventually switch to, so what's cool on the MacBooks with the M1 processing chip, you can install apps for iPad and iPhone. I think as long as you declare it when you're, pushing out the bundle to Apple, um, uh, MacBooks, MacBook M1s are able to run such applications. And that's really cool. I did not realize Stacy checking in. Stacy from the Villanova Computer Science program. Thanks so much for your words on LinkedIn, Stacy. They were so nice. But I didn't realize we were up to 10 5-star reviews in the Apple iOS Star. That's really cool. So that's awesome. I am beyond thankful, but please, keep them coming. That's awesome. So what's cool is if you do, and they're newer, obviously they're all the new MacBooks that have the M1 chip. But if you do get your hands on one, you can run certain iOS and iPad apps, and this is one of them. So I think I'll eventually switch to that. But let's first just start with the iOS. So this is just simulating an iPhone 13. I think just a plain old iPhone 13. So I've just set West Hampton, New Jersey to my location for one reason or another here in Burlington County. So I think what happens if I hit, all right, I'm going to hit update current location. I think this defaults to Florence, which is not where I'm located anymore, but that was the town I used to live in. So this is like, you first open up the app, it asks for your location. This is what it gives you, a list of stations. Now I have to say, just from my use case standpoint, I typically run it in the week mode, probably just because, again, I have the DX, sort of interest. But I also think, I don't know, driving in a car, like much of this is reasonable, particularly with today's car radios. Now, there are some exceptions. We'll talk about those later. I think there's probably a good one here. Like, so a couple folks have brought this up. Like, BEB in Philly has an 82 decibel, I'm going to mess it up, decibel volts per meter. I forget what it actually means. But this is a local quality signal here in Florence. It just so happens that the New York FMs do, and I can say this from living there from almost 20 years. The New York FMs, put in decent signals. I mean, not great, but these readings are accurate, like somewhere in the 40s, which I feel like our categories are fairly on the mark as far as